All right, so I just finished dropping the cans and smushing the little clay ball. So on your chart, it shows you, I'll just kind of zoom in on this. Height 1, which is right here, and then height 2 was the 20 centimeters. So this was the shorter height and then the higher one. A and B, I was like, what's A and B? Well, they're assuming that half of the groups in the class are doing the small can and half the groups are doing the large can. So what the A and the B are A is the small can and B is the large can. So I did all of them. I did all 3 trials for both cans, high at 20 centimeters and then lower at 10 centimeters. So what I'm going to do, I'm going to share the data with you in a minute, but I'm going to read through the conclusion questions with you really quick because I'm just going to leave the data up there so you can kind of keep it running until the end, so that way you can copy everything down. I highlighted a couple things. I kind of wrote on it. I tried to, at least, so that way it kind of, and I'll explain it to you before I finish the video. All right, so the conclusion questions are, what are the advantages of calculating an average value when doing an experiment? So why did we do it 3 times for each scenario? Why do you think that would be a smart thing to do in an experiment? 2, from which dropping height was the average thickness changed the most? So which one had the biggest change? 3, and I don't want like yes or no answers. Like I want, some explanation behind the answers, please. Question 3, what can you conclude about the relation between height and energy? Again, use the data. Give me a good explanation. The follow-up questions, if you choose to do them, they're going to be considered extra credit. Your group used an object with a fixed mass. It was either heavy or light. So A was the lighter can, B was the heavier can that I did. How will the results be different for an object with a different mass? Okay, so let's say we had something that was even bigger than the dog food can, or something that was maybe half the size of the cat food can. Okay. And then question 5 kind of brings us back to that original activity that we did, investigating kinetic energy, activity 2.2. It says you found a relationship between speed and energy. That was the one where we dropped the can, and then the second time we forced it. We added some force to it. What is the relationship between the speed of impact and the dropping height? So do you see some similarities or some differences between the speed of the can when we did it in activity 2.2 and or the height that we tested in this activity 3.1? Okay. So, again, I would like you to try all the questions. If you try them at least, maybe I'll give you an extra 5 points on your lowest, alternative assessment or your lowest quiz or something like that, okay? So, here is I'm going to try and do this. It would help if I brought it up. So, here is the data. Hang on. This way. Okay, so I highlighted, let me see if I can get this to stay. There we go. So I highlighted this is going to be hard to do. Where's my finger? There we go. Okay, so I highlighted, this is from 10 centimeters, and then this is your 20 centimeters. You can see I highlighted A is a small can, B is the large can. Okay, T0. This is the size of the clay ball at the beginning. That's why they are all 3s, because when we started, before I dropped any cans, T0 represents the thickness of the ball at the beginning. Okay, and that's kind of what I put at the top here. The thickness of the clay ball at the beginning was 3 centimeters. Okay, T1 is my first drop for each of them. T2 is my second. T3 is the third. Okay, I showed you all the calculations right here. Okay, you were supposed to find the average. So how you find the average is you take T1, T2, and T3, and you add them together, and then you divide by 3. That's how you find the average or the mean of something. So I did that for all 3 of them. You took T1, T2, T3, you added them and divided. So the highlighted in this column is your final average. Okay, I do want you putting all of these numbers in your box, though. All right, so copy it exactly how it's shown on here. Okay, then the thickness change is you're going to take your T0, which again was the beginning clay ball. Where are you? Woo, here we go. T0 was 3s. Okay, and then we're taking our difference. We're taking you know, the thickness of the ball minus the average, and then you're subtracting it. Okay, so then we took our thickness of the ball. Wait a minute. Here, oh, no. What just happened? Oh, there we go. It timed out. Then you're taking the thickness of the ball that started with, the average that it kind of dropped, and this is your average thickness change. Okay, so that's what these numbers are in this column. And then you have the final, it says average thickness change in that last column. Okay, so I'll leave this up here, even if you just want to pause it and leave it here and you can fill in the numbers, it's up to you. But when you are done copying all of this in, I want to see the calculations and everything. Just copy it exactly the way that I did it, and put it into Genesis, or not Genesis, oh my goodness, into iQuest. You can see that it is under data collection and observation. That's where this table is found. All right, and then underneath of this are your conclusion questions. You must complete at least numbers 1, 2, 3. 1, 2, and 3. And you can try questions 4 and 5. You should be able to do them. They're pretty, you know, if you just recall the information that we did in 2.2, you should be fine. Okay, so this is activity 3.1. This is to be done on Wednesday, April 1st.